Okay, 5.5 is the word problems for quadratics. Okay, so the first question is that we have an equation that's given to us, and it's about a buffalo that is going over the edge of a cliff, and this is the height, and then this is the time. X is the time in seconds. Okay, so what we're going to do is we're going to input it. Okay, so y equals, we input it. We'll see what it looks like. If I just do a normal zoom 6. Okay, so I'm just going to adjust that I want a little bit higher on my y. Okay, and if you really want, maybe we don't need as much x. Okay, so trace, so 0, so this buffalo starts 12 meters above the ground, and what we want to know, how long was it in the air? So here's the buffalo. When it jumps, it's falling, 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 and it hits the ground. So this is really the only piece of the equation that actually exists. So right here, time is 0. This is what we want to know, the time. This is 12 meters up. And so this line right here would be 0 meters when it hits the ground. So we want to know that. So all we do is we calculate the 0. And we're to the left of it. And I'm just going to go that I see the x value of 2 is on the right of it. So 1.56 seconds is the answer. The ball is thrown from a bridge. So here's the equation. So I'll let you read the question. So we have height in meters and then time in seconds. So we're going to enter this. So negative 4.9x squared plus 8x plus 14. Let's see what happens on our zoom 6. So we need not as much x and we need higher y again. So I'm just going to go negative 5 to 5. Let's go 20 and go up by 2's. And that looks pretty good, actually. I'm going to activate my trace. Oh, I didn't want to do that. Okay. Okay, activating my trace button. So there's the point 014. And then the ball goes up. And then it hits. Okay, and so that's kind of what I know right away, that it goes up and then it hits. So when is the ball 16 meters above the water? When is the ball 12 meters? Okay, so here's what we're going to do. We're going to go 16 in our y2 graph. So when is it 16 meters? Right here and right here. So calculate the intersection. So this is 0.31 seconds. And then calculate the intersection. So now I'm going to move my cursor so that it's closer to this intersection so it knows to find that one. And 1.32 seconds. So those are the answers for the first one. When is the ball 12 meters above the water? So if this is 14, 12 is going to be down here. So in my calculator, I'm going to get rid of the 16 now, and I'm going to go with a 12. Okay, so I'm trying to find that intersection. So I'm actually going to move, say, I just want to put my cursor over there. Okay, so calculate intersection. 1, 2, 3 enters. So that intersection is at 1.85 seconds. Is the ball ever 18 meters above the water? Okay, so actually what we need to do is find this max now. I'm gonna get rid of this. So graph, second calculate your max, left bound, right bound. So 17.3 is the highest. So no, the highest it would ever go, and it would fall back. So, and when does the ball hit the water? So that would be this point right here. So calculate the 0, and I can kind of see it's between 2 and 3. So 2, enter, 3, enter, 2.69. The length of a rectangle garden is 4 more than its width. Determine the dimensions if the area is 117 meters squared. Okay, so we know that about the area of a rectangle. And the length of the rectangle is 4 more than its width. Okay, so that's the mathematical sentence of that. So what I'm going to do is I'm going to take this statement, and since it's equal to L, I'm going to go in there and replace it. So length times width. Okay, now I'm going to go in here since this is a quadratic, and I don't even need to FOIL it all out. I'm just going to go x plus 4. So I'm going to enter just like that, because now I have the same variable. Do you understand why I couldn't do that here? Because this is like an x, and you can't have two variables when you start typing into your calculator. Okay, zoom 6 on this just to see. Okay, so when does this equal 117? So 117. I do know that my window is going to have to get pretty high now, right? Okay, so that would be what I'm looking for right there. So let's put our cursor over there at 8 maybe. Okay, so calculate the intersection. And it intersects at 9. So when the W equals 9, so if W equals 9, length would equal 9 plus 4 or 13. Okay, and the reason I wouldn't want the intersection, it is going to intersect over here. I'll just show you. The reason I don't want this intersection is because it's at a negative x value, which would make this a negative W, and you can't have negative dimensional lengths and widths. Okay, Paulette owns a store. Video games is what they're selling. So she charges $10 for each used game. At that price, she sells 70, and then if she increases her price by $1, then 5 fewer games are sold each week. So we're going to go revenue equals the price times items sold. That's how you make your revenue. So the price starts at $10, and the items that she sells starts at 70. Okay, so now this price though, if we increase it by $1, but we don't know how many increases we'll do, then this goes down by 5. So if this goes up by 1, this goes down by 5. If this goes up 2, this goes down 10. Okay, we need the x there because we don't know. So what we're going to do is go to our calculator now. We don't even need to FOIL it. Our calculator does that kind of work for us. Okay, I'm just going to cheat with my table here. All right, I'm in the 700s, so let's just put this at 1,000 maybe, going up by hundreds. Negative 10 to 10 just to see. Okay, so there's our quadratic. What price should she sell to maximize her revenue? So we would want to calculate the maximum. Left bound I can enter already, right bound. So 2, 720 is the coordinate up there. So when x equals 2 is what maximizes her revenue. So when x equals 2, so here the question says what price would she sell her games? So the price would be 10 plus 2 or $12. What would her max revenue be? Well, revenue is the y, and in our case, this is the y. Okay, so now we have a launch of a rocket, So the initial velocity, 30 meters. Okay, so what do we know? We know 2 seconds, a height of 44. That's a point. And the rocket was in the air for 6 seconds. So we know that is another point. Okay. So right now that is what we know. And it's launched from the ground. Okay, so we know 3 points on this graph, so I'm going to draw it. Okay, so those are our two intercepts. So we could play around with our factored form. Okay, I also know that my vertex is going to be halfway. I know that. And then I know that this point is 2, 44. Okay, so that's the things I know. So determine the equation. Okay, so y equals a, x minus r, x minus s. That's the factored form. So I'm going to put a 0 and a 6 in, because those are my intercepts. And I'm going to replace my x and my y with that point that I know. So 44 goes there, 2 goes there, 2 goes there. So 44 divided by negative 8 is a. I'm not sure, does that come out to something nice for us? Negative 5.5. Okay, so y equals negative 5.5, x minus 0, x minus 6. Essentially, you don't really need to even put this in there, right? You don't need to state minus 0. Okay, so let's graph that, because we had to make the equation before we did anything. Okay, so there's my type in. Let's go zoom 6. I'm probably going to have to increase my y because I knew that was 44. So let's go up to 100. Okay, so trace. Let's just check this out. 2 comma 44, 6 comma 0. So those are the points we were confirming. We did know our max was up there. Okay, determine the quadratic function. We did that. State the domain and the range. So the domain is the time, which starts at 0 to 6. And the range is the lowest height it would ever be is 0, and the highest is 49.5. Okay, and I guess again I could have just maybe double checked that my max is actually that. Okay, bus company is charging $2 and they want to raise their price. So this is the model that maximizes their revenue. X is the number of 10-cent price increases and R is the revenue. Okay, so I'm going to type this in. Okay, my Y's are going to get pretty big, I think. So 30,000, let's go maybe. Up by thousands. Try that, see what happens. Okay, I'm also going to go on my X from negative 30 to 30 maybe. That looks better. Okay, so what should the price ticket be if the bus company wants to collect a revenue of $21,000? So let's enter 21,000 in our Y2. Okay, so we have 2 intersection points, so we're going to calculate intersection. Okay, I'm just going to move my cursor over there. Oh, that's actually pretty close. I was actually right on. Intersection 1, 2, 3, and we get 15. Okay, so if x was negative 5, we started at $2, and then we would go down 5 increments of 10 cents. Okay, so $2 minus 50 cents, so they could charge $1.50. Okay, or if x was 15, they would start at $2 and go up 15 10-cent increments. So that's $1.50 of increase, so $3.50 they could have charged, or $1.50. Okay, rectangular garden, we know the dimensions, and then there's going to be crushed rock around it. So there's the garden, and then there's the crushed rock. Okay, so we don't know the dimensions of this, so we're gonna, it's a uniform border, so this is gonna be x wide, and so is this, because it's a uniform border. Okay, so now I can see that this total length is 6.25 plus 2x. Do you see why it's 2x? Because we have an x on both sides. And this is 5 plus 2x. So this is our inside dimension and our outside dimension. Okay, what do we know? We know she wants 6 meters squared of crushed rock. So the area of the whole thing minus the center area would be the area of the rock. Okay, so that's just me writing in words. The area of all minus the area of the middle is the area of the border. So the area of all so length times width minus the area of the middle. We can do that. 5 times 6.25 has to equal 6. Okay, so if you want, you can type that in, and then y2 you can type as 6, or we could type this in into y1 and move that to that side. And then do that intersection. Okay, so there could be various ways to do that. Okay, so 6.25 plus 2x in brackets. There's my y1 and 37.25. Okay, what are we getting here? So we're in the 600s, so let's go to a max of 1,000. Ooh, don't need to be that high. Okay, let's try a max of 100 then. That's a little better. Okay, calculate the intersection. So x equals 0.255. Okay, I don't want this intersection because that's an x value of negative, and in this case x is the dimension of that, the thickness of the border. Okay, so here's the border thickness, or width in meters. Okay. A company manufactures aluminum cans. So we know the height and we know the volume. So determine the radius. So we can just do algebra here. So volume equals pi r squared h. Okay, so that is the volume of a cylinder. So there's my volume, pi r squared times 18. Okay, so if you wanted to, you could type this into y1 and this into y2. Okay, and figure out the intersection. I think this is kind of easy enough to do with algebra. So 1500, just be careful here how you type it in because you got to divide by in brackets. You need brackets on that. And then square root my answer, 4.5. Okay, we'll go 5.1. Graph this function to determine the radius. So now, since we did it with algebra, we are going to do it also with our calculator. So 0 equals pi r squared, replace with the 18, and replace with that. Okay, so pi x squared times 18 minus 1150. What's our table at? Oh, we're getting high here. Let's try 15,000. See what happens. Okay, we want to know where does this equal 0. So we want to know this intersection. So calculate the 0, left, move it to the right, and 4.51. It's the same result. So which method do you prefer? It just would be up to you. Okay, next one. The sum of two numbers is 11, so a plus b equals 11. Their product is negative 152, so a times b equals negative 152. So what I'm going to do is I'm going to rearrange here and isolate something. Okay, so I moved the b over. So now this is equal to a, so I can go in there and replace my a. Okay, so now I'm going to go into my calculator. Bracket 11 minus x times x, and then negative 152. So in my window, let's go from negative 500 to 500 maybe. Okay, so we want the intersections. So calculate intersection, enter, enter, enter. So x equals negative 8. I'm going to move my cursor. Calculate the intersection. Enter, enter, enter. X equals 19. So those two numbers, they would add to 11, check. And when you multiply them, they multiply to negative 152. Okay, a donut store sells donuts with jam centers. They want the area of the jam to be equal to the area of the out. So that's the out, and that's the jam. Okay, the outer radius of the whole donut is 6. Okay, and then I'm going to call this radius x then, because I don't know. Okay, so the area of the outside is going to be equal to the area of the inside. So the area of the out is pi r squared, and the area of the in, the area of the out is that, but we're going to have to take away the area of the inside, right? Because it's being cut out. So pi x squared, and that has to equal the area of the in. Okay, so it doesn't matter at this point what you want to do. Do you want to just do this as a y1 and this as a y2? Do you want to move it and make it 0 and find the zeros? It doesn't matter. Since I don't want to make any algebraic mistakes, we'll just go pi times 6 squared minus pi x squared and pi x squared. Let's look at our table. Oh man, what do we want to do here? 2000. We'll just go negative 2000 to 2000, see what happens. Okay, we do have some intersections, so I'm not going to go as high as I did so I can see them better. Okay, and I want that intersection only because I don't want a negative x value. So 4.24 is the x, which is the radius of the inside, and that is in centimeters. Okay, Duncan dives. He dives off a 7.5 meter platform. So that's what he's doing, and then he reaches a max height, and then he falls to the water. Okay, so we're going to make an equation, so I'm going to use vertex form, because I know the vertex. So the vertex I'm going to fill in with a 0.3 and a 7.94. And for the x and y, I'm going to use 0 and 7.5. Okay, so now I am going to determine my a. So I'm going to subtract 7.94. Negative 0.44 equals a, and then 0.3 squared, so this is 0.09. So negative 0.44 divided by 0.09 equals the a. Not sure if that comes out so nice. It doesn't, so we're just going to leave it as that fraction then. So y equals negative 0.44 divided by 0.09, x minus 0.3 squared plus 7.94. So y equals, and let's type that in. So I need some brackets around that number. X minus 0.3 squared plus 7.94. Okay, I'm going to go with zoom 6 because I know I'm only going as high as that. Okay, so trace, let's just check this out. 0, yeah, 7.5 at 0.3 seconds, we're at 7.94. So where does he hit the water? So we're going to calculate a 0. So left bound, right bound, and enter at 1.57 seconds.